And I'm glad to see that people are interested in cytometry as a career, because I don't know myself, as I think I've said to a number of people, you know, I fell in love with cytometry as a student and have never really fallen out of love with it. No matter what sort of things seem to have got in the way. So what I thought I'd do is I'd set up a few questions and let the panel discuss it. And once, if people have things to add to that, you're welcome. I think show a hand in the Zoom screen, and Avril or I will ask you to unmute yourself, and away you go. Everyone is naturally muted to start with, but please, if you're going to speak, remember to unmute yourself. It's of course a standing joke in Zoom these days with COVID that people haven't unmuted. They set about saying a lot of things and forget to unmute themselves. Before I start though, I'd like to introduce the panel. This is not in a particular order. I'm just going to start with Matthew, who is an associate professor and head of discipline of pathology and the Laboratory of Science at the University of Western Australia. He's been very interested in principally in platelet biology all his scientific life. But he's been substantially involved in enabling technologies, especially in the flow area, all of this time, and of course really stands as one of the beacons in Western Australian flow cytometry and cytometry in general. He calls himself a platelet enthusiast and flow cytometry tragic. So I think that pretty much defines him. Our next panelist is Jennifer Sue. I hope I pronounced that correctly, Jennifer. Jennifer started her career with a PhD looking at translational immunology in myeloma, and really she has attempted to continue this in the hospital environment, really. She's working for New South Wales Health Pathology, based in ICPMR at Westmead Hospital. And she's looking, of course, at routine clinical flow, which of course has its challenges as well as creative issues to solve. And she's looking, in particular, her interests involve the minimal residual disease monitoring in acute myeloid leukemia and acute lymphoid leukemias. So she has a very strong interest in those blood cancers. Steve Allen, one of the people that I really know, I say really know, but really have had a lot to do with, perhaps that is the better way of putting it, because he's been part of our own flow cytometry core for a good while. Completed his undergraduate science degree at the University of Sydney, so he hasn't moved far from the tree, as it were. He's done a couple of things in his life, but you know, he points out that a lot of all of this stuff is associated with wanting to understand how things actually work. So he does a lot of taking apart and putting things back together, and of course he continues to do this in the flow cytometry. He's one of our outstanding technical whizzes in flow cytometry. He, of course, is drawn to the cutting-edge technology we have here, but also has a lot of experience in PC3, which is actually very useful in the current environment, as you'll appreciate. He's the principal scientist of hematopathology at Peter MacCallum. Okay, so he's on the ACS guidelines clinical guidelines task force to focus on leukemia and lymphoma. And he's been co-chair and committee member of past ACS conferences. He's an honorary lecturer at the Royal College of Pathologists of Australia and RMIT and clinical flow cytometry. So he's of course based in Melbourne. He's a NATA assessor, so he obviously enables people to set up their environments so that they're able to run safely and of course accurately and well, and all the rest of the important elements that are associated with clinical work. He's been involved in holding flow workshops in the ASEAN region, of course, as you might expect, and he's also a working party member on the International Council for Standardization in Hematology. Hira Saeed. Hira is a developmental cytometrist at the Garvin Weitzman Center for Cellular Genomics at the Garvin Institute, which is just across town from us in New South Wales, in Sydney, of course. She's been a cytometrist for, she says, 6.5. It's very accurate, which is what you'd expect from a cytometrist. Having completed her Bachelor of Biomedical Engineering and Bachelor of Science from the University of Sydney. So she has a really great advantage because she has a facility integrating flow cytometry with genomics, with single-cell sequencing, with bioinformatics. And so she's delighted, of course, because there's not only so much new to learn, but there's all of these new things exercising her mind constantly. Now, Rachel Errington, at this point, last but by no means least, is, of course, the president-elect of the International Society for the Advancement of Cytometry, ISAC, which most of you will have at least heard of, if not know, which puts on a wonderful conference every year at some useful place in the world to have fun in. She's Director of Cancer and Genetics at the School of Medicine at Cardiff University, and a non-executive director of a company called Biostatus, which is in fact one of the companies majorly responsible for the development of the DRAC probes, which many of you will be familiar with. And Rachel herself has been responsible for the translation and the development of many of these DRAC probes that are now widely in use as nuclear dyes and other approaches to indicating what's going on. She's the chair of the Tissue Microenvironment Group, and she enables creative collaboration between engineering, physical sciences, clinicians is one of the essential cores of Rachel's attitude to cytometry, is the combination of various individuals. So she tends to focus on the cellular and molecular dynamics of various cancers, and many of you will have heard the talk by Shapiro yesterday, how this is becoming really crucially important in understanding how cancers work. So she has a quote. She said, she feels, and I think this really describes her well, all good innovators find a way to get good ideas and technologies into the hands of others. And so I think it's clear that she is really practices what she preaches. Now, is Jeff here? I might introduce him anyway. Jeff works at BD, but Jeff is actually an old colleague of mine that goes back to the ANU times, when we actually had a Consort 40 in the bowels of the John Curtin School, which has since been demolished and rebuilt. He currently leads, he went on from there to Queensland, where he essentially led the cytometry department there, collaborating with a wide variety of individuals and developing novel equipment and techniques associated with flow cytometry in the investigation of brain development and, of course, and disease. He has since taken up a position of Director of Special Order Research Products for BD Biosciences, and now is in San Jose. He leads a large team focused on various customer needs, solving problems by engineering technology to enable this with flow cytometries that fit particular roles of interest. Well, I think that covers the wide range of possibilities, at least in part, for the possibility of cytometry as a career. And I hope we can now discuss the sorts of things that these individuals see as being the essence of what they do and why they love it so much. So I'm going to start with the panel and just ask if you wanted to summarize your job in a single sentence or 2 sentences, I'll allow you. What would your sentence be? Should we start with Jennifer? How do you see yourself?
Sure. So my job is essentially to use flow cytometry as the tool to help to diagnose and monitor patients with various immune or hematological disorders, including malignancies. So I guess for me, the fun comes trying to find those rare cells that are still there post-chemo.
Great, thanks, Jennifer. Rachel, how do you see yourself? You've got a very complex background, so
yeah, so I'm not a flow cytometrist. I'm a cytometrist that uses imaging and microscopy to look at cells and tissue. So I lead a research team to focusing on tissue microenvironment, developing new tools and biosensors. But really, what we're aiming to do is to convert images to numbers to models. And make predictive models that allow us to understand the underpinning biology.
Wonderful. Steve?
Yeah, so I'd summarize my position as I'm a member of a team who support researchers' flow cytometric needs by maintaining the equipment, by training the researchers, running cell sorters and other of the more complex equipment, and administering the facility management side of things for bookings and cost recovery.
All right. Hira?
Stephen and I have very similar roles, so I think he pretty much hit the nail on the head for me as well. So being part of a facility, a lot of our work is to help researchers perform their experiments, do cell sorting, their analysis, and just really kind of maintain the instruments, deal with breakdowns, and then just the day-to-day dealings of a flow cytometry lab. So yeah.
So a lot of interpersonal interaction then.
Yes.
To what extent is that part of a crucial part of your dealings?
So for me, that I would say it's probably 95% of what I do. So a lot of it is you could kind of see it as really good customer service. You have to be understanding of so a researcher comes to you with a problem, and you really have to understand what they're trying to get across. And often if they're lacking in cytometry knowledge, you kind of have to fill in the gaps and then sort of help them get to their final goal. So I think having a great sort of really good communication skills is really important in our field, and also being patient. I find that's a key as well.
So it's an interesting point, isn't it, Steve, that really you have to be a bit of a teacher, but you have to be an extremely good listener in order to enable this to happen without the knowledge, in inverted commas, of the cytometrist as such.
Definitely, yeah. I mean, a big part of it is working out what the researchers' needs are, and communicating with them and hearing, how they want to design their experiment, what they want at the end of it, and all that sort of thing. Yeah, it's definitely a lot of communication and listening and that sort of thing.
Vuong, how would you describe your approach?
Yeah, firstly, I just want to say I'm quite impressed with the widespread contingent from not just Australia, but around the world in this meeting today. It's quite exciting to see. But my job or career thus far has been a rewarding journey, which I've had opportunities to work within the diagnostic realm, but also collaborate with researchers doing research and development work, translational research, as well as working with other inter-hospital departments for transplant and cancer treatment. So it's organising a whole team to provide research and diagnostic flow cytometry for patient care.
Mm. So there's a bit of a pattern developing here, isn't there? This interaction with people. People who want highly specific things for their patients or for their experiments or whatever is a key element of what we seem to do. Matthew, how would you talk about this?
Found it a bit challenging to summarize in one sentence, Nick.
Yes.
I tend to find that every day I go into work, I'm doing something slightly different to the day before, which is good. I would say that I work with a range of multidisciplinary teams to yield knowledge, tools, and education materials that are of use to scientists and doctors in understanding, diagnosing, monitoring, and treating disease.
Yes, wonderful. Yes. As I say, we are cutting this common core here, that really communication is really the key. The ability to see and understand what other people are after, and at the same time, of course, you have to come out of there feeling that you've done a good, responsible, but creative day's work. I mean, what would you what aspects of your own personality do you think make you specific for your job? Rachel, what do you think?
I was thinking about this. I think you have to have a change of personality over time, and evolve a personality, because you start off as a learner, but then you actually become expert and then have to convey that yourself. So your personality has to change over time in order to really develop through a career. I guess fundamental to it is curiosity, and being able and really having a true love for discovery science, but then realizing ultimately you want to be impactful. And so how can you convert that idealistic, as a student, that curiosity into something that will have a long-term impact? And that comes from working with clinicians and really understanding what the that translational bridge is, and trying to think about how basic science and discovery science can be brought to the clinic via cytometry and microscopy and measuring cells and tissues.
Mm-hmm. It's an interesting point that you make about the changing personality, isn't it? But even at the core, though, that you make the point that curiosity is the critical element, and of course, curiosity is really all about learning and all about acquiring and understanding and all of that. So there's always, isn't there, that.
And that never stops, right? That never stops.
Right. Yeah.
And it's now very much data driven, and also fundamentally understanding some of the physics of what you're doing. Presenting a sample to a platform is not a trivial thing. Curiosity, and I think you have to be able to learn all the time.
Mm. Jennifer, what would you think as being the critical elements of your personality that enable you to be an effective cytometrist?
I think it's the same kind of thing for me. I've always enjoyed learning. I was that crazy kid that just loved homework and loved studying. So for me, cytometry is like a big puzzle to solve. So it's always been a challenge. And in my current role, because in clinical flow, it's always the weirdest case that arrives at 4 o'clock on a Friday afternoon, like no questions, that challenges your mind. So if you're not learning constantly and retaining all that information at 4 o'clock on a Friday afternoon, if you don't know what you're doing, you really regret it. So I think for me, it's definitely the puzzle solving, learning always on the fly kind of thing that works for me in my role.
Wong, how do you see that aspect of your personality being so critical to what it is that you ultimately do and love?
Yeah, as a kid who grew up in the 90s, I really enjoyed technology, gadgets, and playing games. And so for me, it's a bit of a transposition, having now flow cytometry as a new sort of gaming modality in a sense, but in a professional manner to provide the service to patient care. And so that interest and that joy is just transposed and interconnected. And that's what sort of drives me to continue to really sort of explore flow cytometry for the many different applications and uses.
I'm hearing echoes of that in Steve's CV. Really, you want to comment about that, Steve?
Yeah, definitely. Yeah, I spent my childhood, playing with appliances or computers or clocks, whatever I got my hands on, being curious about how they operated and taking them apart. And I think that same, it's you were talking about curiosity, Rachel, as well, and Jennifer, and that curiosity for how things work is what I really think gives me like the kind of edge. I want to understand them, and then that understanding feeds back into being able to better troubleshoot problems and that sort of thing as they arise.
It's interesting, isn't it, that troubleshooting is a bit like diagnosis in clinical medicine, in that, for the most part, things are fairly straightforward, but it's that 5% that if you've seen it before, then you're more likely to understand what might be going on. And of course, that's partly experience, it's partly exposure, it's partly training, it's partly a lot of things. But that critical core obsessional memory, in inverted commas, for these, and which of course is driven by interest and curiosity, is so crucial for that. Hira, what do you think?
The thing that I love most about cytometry is it's not like a lot of the other disciplines where you kind of follow a protocol, and the more you stick to the rules of the protocol, the better your outcome is going to be. In cytometry, you really have to think outside the box. You have to really understand what you're working with, because a lot of the times what you're doing doesn't follow a set of rules. When you're setting up something that, if you're running cells that are completely different day to day, it's really about understanding what's going on inside your instrument and then figuring out how you're going to get to the outcome that you need to. So I think the ability to sort of step outside the box a little bit and to think about a system as a whole, I really enjoy that part.
Well, that's wonderful. Matthew, how do you see this?
Yeah, so I mean, the comments about curiosity and the joy of discovery really resonate. I think that's pretty common amongst all of us. I too am a bit tenacious about solving problems. Like, I just can't walk away from a problem until it's solved, and so that's that sort of translates to a pretty a good work ethic as well, which I think is something that you'll probably find is pretty common amongst the people in the panel. And it's easy to have a good work ethic when you love what you're doing. I like to feel useful and like to feel like I'm making a difference, and that helps when working with a range of different teams. If you feel like you're adding a value there, then you're often happy to continue working. And I sort of really yeah, again, resonated with what Rachel was saying about an evolving personality over time. And I think one of the things that you might need to evolve is just an ability to just continuously be right at the edge of your comfort zone, you know, really pushing the limits of what you're able to do each day, and just not only be comfortable with that, but actually look forward to that as part of what I'm doing on a day-to-day basis. And yeah, one of the things about cytometry that's really amazing is I think we all share just an interest in understanding how things work, in really accurate measurement of cells or whatever cell it is that you're working with. But the diversity of applications is absolutely, you know, mind-boggling. You know, I'm really interested in looking at platelets. Nick, you might be more interested in looking at monocytes or microglial cells or something like that. Others might be looking at lymphocytes or blast cells. But in my role, I've worked with just a range of different things. We've looked at, you know, sea plankton, we've looked at wastewater treatment, we've looked at bee sperm, just a completely wild range of different applications. And it's really just pushing the limits of what I'm comfortable doing, and then walking away with a new experience and a new skill at the end of the day. Mm.
Well, it's interesting you make that point about tenacity, because I recall as a much younger and much more junior academic, working for 18 months on developing a plant assay for somebody at UNSW, and getting it out and getting a couple of publications out of it, believe it or not, and just the satisfaction and association with that. And then subsequently, a student said to me, this wasn't near to that particular place, but subsequently a student said to me, you know, if you love what you do, you never have to work. And I'd never had it put to me quite like that before. And my students taught me much more than I've ever taught them, I've no doubt. But you're making that very point, Matthew, is that you're driven by that tenacity is driven by that curiosity and by that enthusiasm and by all of that. And all of you seem to be, exuding that extraordinary enthusiasm associated with all of this. So really, I mean, you know, I think the point here is that, you know, there are aspects of investigation that are technical, and the danger is that outsiders may view such people. For example, I'm a pathologist, but people outside of pathology view pathologists as technicians. You send off a sample to the pathologist and ask what the answer is, rather than a collaboration. And what you guys are accentuating is the point that this is a collaboration between the person who is doing things and the outcomes for everybody. I think this is really an important point, and should be probably more widely realized, I believe. So I'm going to ask her some little pointy questions here, but everybody feels they've got strengths in certain areas. Everybody's aware of weaknesses in others, and I was going to ask, what aspects do you think you lack that you've had to develop or make up for, or even cover up? Because covering up is as good if you don't have to use those aspects that is not as good. I'm going to start with you, Rachel, because I think you probably know more than anyone else about these sorts of things.
So what I've had to learn is how to really communicate well, and communicate by speaking, by writing, and to different kinds of stakeholders, and that has been that for me has been a real challenge, is developing that, and that I think has been it was a weakness, and I think as you sort of get more confident and more expert in what you're doing, you build up that capacity. So communication has been one of the key things that I think I've needed to develop, because you have to be able to write down your science, you have to be able to communicate your science, and you have to be able to get investment in your science, and that all requires really good communication, and be able to communicate to different kinds of audiences as well, in order to get to get those stakeholders to support you in whatever means. And then the other one has been to develop that skills, which I don't think I had at the start, of being diplomatic. And so really realizing that you can't just keep telling people that they're doing something wrong or they're not thinking correctly, that you have to be far more diplomatic than that. And that art of really being able to bridge that gap and understand that you're sitting at a sort of multidisciplinary place. And so that's where you have to sort of understand that not everybody is going to be on board with what you're saying, because perhaps you're not doing a very good job at communicating it in the end. So it's realizing that you can't just be as blunt as you perhaps want to be. And I've developed that skill base, because in the end it's about enabling individuals, as well as getting investment, as well as developing teams, etc. So you have to be much better at communicating and being supportive in how you communicate.
That's wonderfully insightful. Two comments I would make is one is that have you found that that's translated to other aspects of your life? Because often what one learns in one's work life can be quite useful elsewhere.
So it has helped me in other aspects of doing my job, and that is taking up leadership roles and etc., where really you become disassociated from the me specifically and converting it into the we, and how do you make a whole organization operate on good communication, altruistic thinking, teamwork and alignment, which really cytometry teaches you to do that really well, because it's about bringing disciplines together. And so being able to communicate across disciplines has really helped me in being able to convert some of that into leadership and management skills.
Yes, that's wonderful. That's wonderful. How do you see that, Matthew, in your ambit? Matthew?
Sorry, you cut out for a second there, so I wasn't sure if you were talking to me. Could you repeat the question?
Well, I was just going to say, how do you see what Rachel was saying in your own ambit?
Oh, the communication skills, I think, are important. And again, this is sort of talking about that journey throughout your career and building that. And I would say I'm still on that journey. That's something that I'm still continually trying to improve. And I think, it's also an area of learning to pick your battles a little bit. Sometimes you can't necessarily achieve everything or change everyone's mind to share the same view as you or something like that. So some sort of compromise and being able to do that. I think the area that I really had to overcome in order to be successful in leading teams was that I'm sort of generally fairly introverted and quite risk averse by nature. And so I had to learn to really go out of my comfort zone in order to meet the people who I needed to interact with in order to achieve something that, I couldn't interact with, I couldn't achieve by myself. Networking and things like that are not skills that I necessarily had going into my PhD, and those are sorts of things that I've been building over my career as well. I still get a bit, like I'm a lecturer, so I do dozens of lectures each year, and I still get very nervous before each lecture. I think, public speaking is still something that terrifies me a little bit. So that's something that I sort of had to overcome as well, is just that nervousness and speaking to people and that sort of thing as well. Even these sorts of meetings, I get a little bit nervous just speaking to groups of people, and that's something that you sort of learn to bluff your way through or overcome through the course of your career.
Yes. And as for your risk averseness, are you buying a weekly lotto ticket these days
No, I'm not a gambler, but no, I think you learn to, I guess, once you experience failure a few times or setbacks, and you realize it's not the end of the world to put something on the line and build back from it. It becomes less of a a real fear of that sort of thing. And so that works in all aspects. Obviously, experiments, we always experience failure of experiments, and we need to sort of walk away from it, rethink it, and try again. But the same thing works in terms of taking a risk in collaborating with someone. Sometimes it's not positive for both people, but it's not the end of the world. And the wins that you get out of that sort of approach far outweigh any sort of time wasted or loss of publications that you might get from a non-productive collaboration. So yeah, overcoming that risk averseness and just having a go.
Yeah, it's interesting you should say that, because I'm fond of saying that I've actually learned much more from my anti-mentors than my mentors.
Yeah, that's interesting.
Vuong, how do you see these elements, things that you've had to beef up on, things that you still find problematic?
Yeah, I think the psychosocial components, and not just the communication skills that we just spoken about, but having the ability to adapt to the ever-changing environment and technology, the people who you work with, the requirements from clinicians. These are things that you need to be resilient in, and resilience is probably a component that you sort of learn to develop and grow and nurture, because as starting as young scientists in the industry, you don't quite have that strength. But as Matthew pointed out, you deal with these challenging situations and you learn to grow and become more resilient over time. And I think these are components that takes you through to the leadership role, to be able to look after a whole big wider team and understand when you're at your limits, so that you can actually react to that and then improve for yourself, but also for the well-being of the team as well.
You make an interesting point. I mean, you're really saying that, I mean, society argues that as you get older, you get more fixed in your ways, and that you get more hard-headed about this and that and the other. But, in truth, in curiosity-driven occupations like ours, I think we end up becoming more resilient and more able to tolerate difference and more open-minded. I don't know. What do you think about that, Hira? From your point of view, because of course you're still early in your career.
So one of the things that I struggled with the most was confidence. I had really no confidence when I first came into. I started off my career as very, very junior. I'd just come out of uni. I was still a student when I joined the Garvan. And I think for me, it was always feeling very small and thinking, I don't know anything compared to all of these, really great people that are coming through the door, and, they've got all their PhDs and they're leading these teams, and like, who am I? I don't know anything. So I think for me, overcoming confidence issues was something I had to slowly learn to do. And I was really grateful that I had Rob as my mentor. So he really was really good at kind of teaching me some of the stuff that I needed to learn very early on. And I think I had to understand that there's always going to be things I don't know. There's always going to be, the holes in my knowledge when it comes to understanding the depths of a biological question that someone is putting forward to me. And so I need to understand where I'm going to say, okay, this is what I don't know. I'm, happy to read into it further and educate myself as best I can, but then really kind of staying confident in knowing that I do know some stuff as well. So, yeah.
Yeah. Yes, it's interesting, isn't it? There's a recognition that other people have strengths that you don't, and you have strengths that they don't. And in a way, that negotiation that Rachel was talking about is similar, in that you have a view, you are an expert in an area, But in actual fact, others aren't necessarily expert in that area and don't necessarily understand what you're going on about because of your depth of knowledge, because of their lack. And so that negotiation needs somehow to be taking place. Steve, how have you found it?
Yeah, I completely resonate here with what you're saying. You know, I have a lot of gaps in my biological knowledge. And my degree was, you know, it's a long time ago now, and I haven't, you know, continued working in a biological space, you know, as a researcher. And it's just, yeah, for me, it's been about communicating, you know, what's the researcher's responsibility, you know, for them to tell me, you know, communicate to me what they want from an experiment in a way that I can understand, and you know, and then for me to communicate effectively the limitations or benefits of a particular system or modality, and yeah, just about coming together with that. And yeah, similar to if somebody is doing something in a way that's not optimal, and you know, that kind of tact that Rachel was talking about with trying to communicate, you know, if you see them doing something that I consider wrong, where's the limit of my responsibility in that? I can tell them, oh, look, I think this is what's happening here. I don't think you're getting good data. But at some point, you know, the responsibility for the good data is also 50% shared by them. And if they can't hear what I'm saying, it's, you know, yeah, there's a limit, right? I guess that's it. That's what I'm saying.
So you bring up a really useful point. You know, Jennifer, how do you sort of obviate the issue of getting someone to do something that you see as being correct, that you know is being correct, and then finding that they pretty much ignore you, if I can put it that way, I suppose.
So I guess I come at this from a very different angle. So currently my role is literally to run routine panels for doctors and be able to interpret them to a point, and then the clinician will take it from where I've left off. Before I was in this role, I was a research scientist, and I guess now I look at it as a asset, but we never had anybody to do our flow for us. So we've always had to do it ourselves. And I came from a lab that was searching for dendritic cells and rare antigen-specific T cells. So it was always challenging trying to get our flow right. So I guess I haven't been on the end of being the flow cytometrist in that role, advising the researchers on how to do things, but I have been the researcher watching another researcher do something that I know is not going to work, or the research background watching a clinical panel, which I know is not going to work because it's not considering other things. So I think the key is to be diplomatic, to be able to articulate those alternatives, to encourage someone to trial like a FC block, or, you know, gating out the dead cells, for example, if I think all those antigen-specific cells are actually dead. Things like that. There's always ways to get around. So I think it's diplomacy, really, and showing the facts.
Yeah. Yes.
Can't argue with facts.
Yeah. Well, it's amazing, actually. In this day and age, of course, we see this more and more, that opinion outweighs facts. So it's an interesting...
Unfortunate. I'm a pure scientist at heart.
Yes, exactly, yes. I see that Jeff has joined us. Hi, Jeff. Nice to see you.
Yeah, I would have joined an hour earlier if you told me the right time, Nick.
I don't know what... Did you go off daylight saving in...
We did. We went off daylight saving.
Oh dear.
Over the weekend.
Oh, well, I beg your pardon. I'm sorry. I should have probably set you the time.
Apologies for the delayed entry into the conversation.
Yeah, no, that's all right. That's good. Nice to have you anyway. You know many of the people, Matt. You know, Vaughn
Jeff.
probably, Hira, who works at Garvin Weitzman, Steve Allen, you probably have met in your perambulations, and Rachel, you almost certainly know.
Yep, we've met. Yeah.
And Jennifer, who is also in clinical cytometry. And we're just discussing elements of what we think are important to what we do and ultimately love, really. And we've discussed, you know, what aspects of personality make you a good cytometrist. What aspects do you lack that you've had to develop? And I'm going to go on and ask, really, what you'd avoid if you had to do it all over again.
Is this to me, that question?
Yes. Why don't you start off, Jeff? Why don't you start off?
What to avoid? I'd say the main thing for me is to not taking advantage of opportunities as soon as they arise. And for me, that's been one of the sort of career lessons that I've learned, is that the most important thing you can do really is when a small opportunity presents itself, you really need to make the most of that opportunity. And there's been many opportunities that have come about where they could have come about earlier, and I would have got to that point in my career earlier if I'd taken advantage of an opportunity. And so I've been fortunate enough to have a lot of opportunities, but one was, for example, when I went to work in Canada around in 1999 to 2000, there was just a sniff of an opportunity where a researcher said, "Oh, I'm taking a position up in Canada. They haven't got anyone good there in the cytometry field. Would you be interested in coming and doing that?" So, no, I actually took that opportunity, pardon me, and spent a year in Canada and had a great experience there. And then that gave me exposure to a whole lot of other things. But I now realise in hindsight that there were other comments that people had made in the past where if I'd actually taken people up on a sort of almost a flippant comment or a casual remark, that you can actually make something from those which are really, really impactful to your career. And as I've gone on in my career, I've realised that a little door opens or a chink of light opens when a door is being opened or closed. You want to put your foot in there and really make the most of those opportunities. So that's one bit of advice that I would say to people. Try and do that. And one of the things that I regret not doing earlier, actually.
Rachel, you'd have a comment on that, I imagine.
Yes, so I agree with what Jeffrey's saying there. Also, I would I think the key thing is to make sure that you work for people who are good at what they do, but also want to champion you as well, and they want you to do a good job, and they want to help you achieve that as well, especially at the start of your career. You want champions around you. So, you know, Jeffrey's taken advantage of opportunities that arise. There are people who you want to have. You need champions in all organizations. You need champions around you. The other thing I think is important is that you need to keep connected and keep pushing yourself and adapt and understand that there are different routes to sustaining a career. So I would differentiate doing a job and having a career. And there's quite a lot of at the start in the UK in particular, you start off on fixed term contracts and not permanent positions. And so it's very important as a young cytometrist or a young cell biologist to really think that your total job is 80% doing your job and 20% looking after your career, maybe even more a high percentage of looking after your career. They are not necessarily the same thing. and you have to pay attention to your career and pay attention to where you want to be. And that's not necessarily being really, really good at your job only. There's other things that are going to carve out that career, taking up opportunities, and having a champion. And so you have to think about your career and where you want to go.
Yes, in my experience, there are two types of, I'm going to say supervisors, but what I really mean is people who you report to, I guess. One is the person who never wants to lose you and gets really angry if you suggest that you might move on somewhere. And then there are others who realize that you're actually excellent, and it's inevitable that you'll want to move on and support you to the hilt. And I think both individuals are really expressing that point that you do need to be supported. So you need to find people who will support you.
If you're well networked, there could be champions elsewhere, right? So it's really about making sure that you keep connected.
Yes, that's a good point. Hira, how do you feel about that?
Oh, I think what Rachel just said really resonated with me, because I think I'm at that point at my career right now where, you know, that difference between doing your job really well and where you want to be in your career. So I think that was definitely something I'm really going to think about very hard. So thank you for that, Rachel. Yeah, I think I don't know. I don't know if there is anything that I would avoid to do all over again. Right? That was the question.
Yeah.
I guess, yeah, taking opportunities, definitely going off Jeffrey. I think there have been opportunities that I haven't taken, again, because of, you know, confidence issues or thinking I'm not there yet, right? But if you just go ahead and you just take them and you just do it to the best of your ability, then you just don't know how that's going to, you know, progress your career. So I think that's definitely something. I wish I had that attitude of like, you know, I can do this a lot earlier. So yeah.
Yes.
Yeah, there's a little American expression that I've learnt while I've been here, and it's, we're all a work in progress, right?
Yeah.
And often you don't recognise that everyone's a work in progress throughout their career, and you think, oh, I haven't got the confidence to approach a particular position or take a particular role. But if you have that idea that everyone's a work in progress, then just embrace something and you'll work on it. And if you're driven, you'll normally succeed. So I'm sounding very rah-rah American there, but I actually think it's true, right? That we need to have that attitude that we're all works in progress, and when things don't succeed, possibly how you'd like them to go, just think, well, I'm still learning how to do that, or I'll grasp that concept and I'll move on. So.
Oh, no, I'm very familiar with that concept, Jeff. My wife tells me that I'm a work in progress all the time. Tell me, Jennifer, at your point, would you avoid something? Would you do something differently?
So this is really difficult because for me, I've been through academia, I've been through industry, I've been through clinical flow now. Not every experience I've had has been good, but I think it's shaped who I am now. So I don't regret anything. I think you just got to take the positives from wherever you go. You know, if a boss is being difficult and making something really hard to do, you know, it's a challenge and you're learning to overcome that challenge. Yeah. And I think it helps you with that next position as you move forward.
Yeah.
And of course, you know, you learn things like patience and, you know, how to deal with the conflict.
Yes, I think you make a very, very good point there. And that is the issue. A lot of people, I have a medical degree, just out of curiosity, and I've never practiced very long. I think I practiced a maximum of 5 years and went into research. And often people say to me, oh man, don't you regret having done that medical degree? And I don't. The truth is that it's been very valuable to me in many, many ways. Yes, 7 years down the tubes, you could argue, but no, it was very, very useful. So I think that almost all adversity can be useful if worked upon in some way to one's own benefit. I don't think there's any doubt about that. Yeah. Tell me, what do people regard as the washing up? I always think of every job having the washing up. In other words, stuff that you have to do that you hate and loathe and detest. But in fact, you know, you kind of look out the window while you're doing it and sort of look at the garden, and you know, you do it, it's done well, but you know, you still would rather not if you had to do it. What do you think, Matt? What do you think?
Goodness, there's a lot of it, and it seems to be the more I advance in my career, I seem to be taking on more washing up rather than less. So my role at UWA at the moment is, you know, fairly new into the role, but it's a sort of middle management role. So I lead a discipline. So, you know, there's a lot of washing up to do, things just like scheduling lectures, you know, working through governance applications. This is not the reason why I became a scientist by any means, but it's important work that needs to be done. It can be quite tedious at times as well. You know, contract renewals for staff that you have to go through on a regular basis. You know, leave approvals. I obviously have quite a bit of marking that I need to do, and so you just carve out the time and find a way of getting through that, I think. Yeah, I'm not sure that I can give too much advice on how to do it. I make a little bit of a game of tasks that I need to do by I make a little square, and I put the urgent things in the top and the not urgent things down the bottom, but I also have important things that need to be done and not important things. And you can get very caught up in always dealing with these urgent problems, but you need to think, are they actually important as well, and make sure that you carve out time to deal with the things that may not be urgent, but they're absolutely important to get done. So that's probably, in terms of making a game out of things, I do that whenever I have a task. I try and allocate it based on its urgency and its important to make sure that I do get to all the tasks that I need to do.
Very good, very good. Jeff?
Sorry, I was laughing there because in a large corporation we have you know, a large amount of bureaucracy, and having come from academia and then coming into a large corporation. So for those of you who don't know, BD as a company has 66,000 employees worldwide. And there's a whole lot of other statistics that come with that. And one of them is that we have a huge amount of compliance. And so we have to do online computerized compliance training regularly. And that for me is very much washing up in, it's more like washing up a dirty barbecue plate, Nick, with thick layer of grease scum floating on top of the water, which you have to plunge your hands into at regular intervals. It's for me, that's almost agony. You know, it'll be having to do training on some compliance issue to deal with, you know, interacting with medical professionals when I happen to be traveling in Europe or something like that. Those things for me, it's sort of what Matt was just alluding to. They're important, you have to do them, they're a compliance issue, but I wouldn't say they're urgent or something I look forward to doing at any stage. But that for me is very much washing up grimy, greasy dishes, which I don't want to do.
Fung, you probably have a fair bit in your line of work.
Yeah, transitioning from the bench into, you know, sort of a management role, there's a lot of administrative tasks that Matt had outlined, and you know, I mean, you don't particularly enjoy all of it, but it comes with a job, and you know, you sort of have to sort of do it at intervals in which is appropriate. And for me, trying to sort of operate a 24/7 core laboratory service, which includes blood bank, hematology, flow cytometry, biochemistry, CSR, you constantly have to sort of be at it and make sure that you know, staff are aware of what they're doing, and just making sure that the service provision is ongoing. And there's no way out of that, but it's pivotal and critical to the service.
Yes, that's wonderful. I must say I like the concept of making it a game, That's something that I very much appreciate. When I was a kid, my parents both worked, and we had to prepare supper, and inevitably supper was involved in a lot of potato preparing. So we would have games about how long the longest peel we could make out of a single potato, for example. And I think I've always brought that back to these awful, important, but not intellectually stimulating aspects of my own thing. Rachel, how do you see these things?
So I see I see these things as not so much washing up, but the things that become less about what you want to do and more about enabling others to do their job, and you can consider and therefore that it is really important to be able to provide that put in that effort, and at times only you can do that, and so what I try to do is to give myself some rewards for looking after other people, looking after the team, and carving out some time. And it isn't necessarily during a working day, but some time where I have some pure joy of doing some science of my own that just keeps me ticking over, and that's how I get through that sort of the looking after lots of other people, and that responsibility is to designate the time when I can have 2 or 3 hours of doing some science. And it's not necessarily being in the lab, but looking at data or working with a PhD student or wherever it is. But it is about just doing science, reminding myself why I'm there, and giving myself that grounding. So it's not very many hours per week, but it's enough to keep me engaged and happy.
Yeah. I mean, you make a very, very important point about all of you have made an important point about as you climb the tree. Of course, you have to do more and more other things that you didn't think you signed up for, you didn't realize you'd signed up for, perhaps. And so that idea of reward is a really nice one, Rachel. I have to say, I think it's really a great way to tie that the washing up with the reward. It's a really good idea.
Just as a follow-up to that, Nick.
Yeah.
Just as a follow-up to that, I think the other important point Rachel made there is that you need to make that time for yourself and to do whatever you want to do in your career. You need to make time to find those things that are going to keep you sane, keep you happy, keep you enthused about what you're doing. And it gets harder the higher up within an organisation you get. But for me, I still try and get in the lab for 1 or 2 hours, if not more, a week, and do those little things which keeps you in touch with really what's going on and the day-to-day problems that people have. And then you have much more better understanding of what people's real issues are. And then it also changes the way you view how you do some of those other aspects of the job. So I think that making time is really important there.
Yes, I do agree. Do you see glimpses of this, Hira and Jennifer and Steve? Do you see glimpses of this that would put you off?
No one else. Oh, you
go
go
on, Jennifer.
Okay, I was just going to say, with my background, I think one of the things I didn't realize going through with all of my training was what kind of job that's actually going to be day to day. So, I did the thing of, you do your honours project and you do well, so you should go into a PhD, and then, you should postdoc and you should do this and you should do that. But I never really understood exactly what that meant. But for me, as I've gone on, that's what I mean. You try different things, you see, how this job fits you or doesn't fit you. And the other thing to factor in is life, of course. And I think one of the women on this panel who have children. I've got 3, my 4-year-old sitting next to me colouring in. I think it's one of those, you have to balance the life versus work versus, you know, what you're getting out of this. And for me, I like that mental challenge, but I don't want to be overwhelmed. So I think, I mean, I might sound like yes, Charlotte. I might sound like I'm a little bit of a downer, but I think it's a really, it's a practical consideration. You know, you can reach for the stars, sure, keep going, but if that's not the lifestyle that you want, then don't do it, and that's okay. And you can be really good at a job and still be happy doing it without reaching for the very top of the ladder.
That's a really important counterpoint that you make. Very important counterpoint that you make, Jennifer. It really is. Hira, what do you think?
So with the question originally, the washing up in our job, I think for me and for Stephen as well, being part of a team that manages a facility, our washing up is can quite be very literal at times. So we are actually washing up, which is immensely tedious, especially when you're washing up after researchers. And so, you know, for us, it's about doing long cleans on our instrument, maintaining sterility. It's about, you know, making sure our instruments are working properly and, you know, doing those checks. And, you know, for me around the lab, I do a lot of inductions and a lot of safety checks. So that sort of stuff is, it's you know, that's the washing up of our job. But it's not, I don't mind it so much, because it kind of can give you a nice little break. And it's but yeah, when it gets to, you know, like a Christmas shutdown period and you have to worry about how you're going to leave all of these instruments over the Christmas break, then it can definitely get quite a lot.
Steve?
Yeah, you hit the nail on the head, Hira. The deep cleans on the machines and the QC, you know, as you say, not necessarily unenjoyable, but something that, and this, you know, I think this was talked about, that you've just got to make sure that you make time for, you know, don't just focus on the exciting parts. Yeah, definitely. I mean, I feel lucky being, you know, part of a team rather than managing the team. Being part of the team, you know, we all sort of gravitate towards, you know, what interests us. And so, you know, for example, you know, my team, we've got, you know, Avril, who does a lot of like the kind of administrative side of, you know, functions, and takes care of all, like, lots of, you know, detail that I kind of wouldn't really find that enjoyable, even as you know, washing up. But yeah, it's good to be part of that team in that way. And that's also, I think it does, and Jennifer, I resonate with what you said about not necessarily wanting to shoot for the stars, because, you know, the idea of going into management for me is probably, you know, whenever I think of that, I think of, well, probably doing less of what I actually enjoy. You know, it's like probably more, you know, tasks that I actually don't like. Yeah, and I'm happy where I am. You know, that's the thing.
Yes, I think those are important elements to balance. No question of it. So coming to that, then, what would make you leave cytometry? Let's start with Vung.
I guess as we sort of spoke about, if you sort of don't have the opportunities to no longer do the things that you enjoy, then, well, it can really sort of steer you off course. But I mean, it's interesting that you said we reward people who do well in their jobs to these management roles, and some people may find ways of circumventing these and make it enjoyable. And you know, I like we spoke about some of these administrative tasks, I try and make it as therapeutic as possible whilst engaging with people, so that it becomes fun and interesting. But at sort of the scientific, sort of, or more the junior scientist level, perhaps if we don't provide them with the appropriate opportunities to partake in these sort of educational activities and conferences, then that could deter them altogether. If there are other more sort of incentives that are provided or sent their way. In pathology in general, we have 3 key disciplines in blood bank, general hematology, and flow cytometry. And if you don't balance that well, they'll find and garner more interest in the other subspecialties, and will probably navigate towards that direction. So, if you want to nurture someone into a particular role, I think you need to mentor them and provide guidance.
Yeah. Yes, that's an important point, isn't it? Matthew, how do you feel about that?
Oh, I think that was a really interesting perspective with Vung, and resonates a lot. I see cytometry as a technology, and technology moves on. And I think there's, in terms of risk, there's a possibility that technology moves on in such a way that my skill set in cytometry is no longer as valuable in advancing science. And I think, if I recognize that would probably make me think of a change in updating my skill set and updating my area there, I think. So if I could, because of the change in technology, no longer be valuable. The other thing that I think keeps me very interested in cytometry are communities like this. I think the ACS is really important in promoting cytometry, and it keeps me engaged with cytometry outside of my day-to-day experience in my job, and other communities as well. So with Rachel on the call, Isaac, I think, is really important as well. And if we didn't have these communities like ACS and Isaac, I really don't think I would be necessarily continuing to engage with cytometry in the way that I do at the moment. I might be moving off into other areas, so that keeps it keeps a thrill there, and it keeps my my knowledge updated. And I think one of the reasons I want to bring that up is because I think the world is changing a little bit, and there is perhaps a risk to communities like ACS and Isaac moving forward, and the way that we exist as a community and an interest group. And it's really important, I think, just to bring our focus back to that, how important ACS and Isaac are to the career advancement of scientists and to the advancement of cytometry as a specialization, to keep us evolving as the technology evolves.
Yeah, thanks, Matthew. You make a very important point. I'm sure that Rachel would like to comment on that.
So I think the thing that would make me leave cytometry is basically other calls in my life that need me more than doing science. That would be the first reason to not to be doing cytometry. But I think Matt brings up a really interesting point, and that is, what is cytometry, and what is the definition of cytometry, and what do we mean by cytometry? It's an evolving technology, science, application, whatever direction that you're coming from, and it's really maybe letting go of the term cytometry eventually, and because it evolves into something else, and that's probably what that will happen over the longer time, is really making sure cytometry is an appropriate terminology that's needed, and an evolving area, and it might mean that cytometry evolves into a different nomenclature and different technology basis.
So I'm going to change it a little bit. I'm going to ask what you think the next big thing is going to be in the next sort of 5-year cycle or thereabouts. Rachel, why don't you start? You come from a completely different, well, not a completely different perspective, a cytometry perspective associated with the architecture of tissues.
So in the horizon scanning terms, I think the ability to integrate data from different modalities, of which cytometry sits, maybe maybe we can say at the heart of it, or and then at times at the periphery of it, but data integration. So to be able to use different kinds of technologies and techniques in order to look at samples and including patient data, etc. So really proper data integration. I think that is a big challenge, and that is that has a whole load of not just technical challenges but ethical challenges associated with it, and it's how you bring all of that, how you bridge across all of that. What I'm interested in currently is spatial genomics, and how we can really use that in the translational field, where we're making decisions on patient stratification and precision oncology. That's what I'm interested in, and so bringing both imaging and genomics together to make decisions on patient treatment.
Yeah. Yes, that's a point echoed by Shapiro. One of the outstanding points I remember he making yesterday was that he was looking at possible ways of actually identifying areas that might be resistant to treatment before treatment, based on the biopsies that he was looking at. What do you think, Vung?
Well, in the clinical sphere, I mean, similar to Rachel as well, there is a strong push for integration of results across multidisciplines, and from molecular pathology through to cytogenetics, flow cytometry in general, hematology. There is that need as well, especially now that immunotherapy is coming as a strong modality for treatment of patients. There is a requirement to look at all facets of ancillary tests to make sure we provide the best sort of diagnosis for the patient. And I guess specific to flow cytometry, there's a real challenge to now modify or sort of implement new markers and panels such that we can circumvent the challenges of no longer being able to detect some of these primary gating markers that we're so used to using in the past, but now we need to be creative and using perhaps, high dimensional flow cytometry to address these concerns. And that's probably things that we'll be working with over the next few years, I'd imagine.
How does this impinge on you, Hira?
I think with what one said, high dimensional flow cytometry, as well as the integration of cytometry into the evolving single cell platforms that we have coming up. So there is so much development in the genomics space at the moment. And I think it's integrating cytometry and genomics together is going to be really exciting. And when you factor in sort of high dimensional cytometry, it's going to be, I feel like that's where the next couple of years is going to be focused on.
Jeff, I mean, how do you see this sort of burgeoning data issue / modality issue? One of the prime problems, of course, is that there are 3, 4, 5 different ways of looking at, let's just say, genomic data. Flow cytometry is moderately uniform as far as it goes, but you don't have to look too far to realize that it could be discrepant. How are we going to, do we integrate all of these modalities? Do we find ways of doing that? Do we plump for one kind of modality? How are we going to approach this?
Well, I'd say everyone's got their own opinion on how that's going to pan out, right? But what I would say is that there'll be pipelines which can deal with data from a range of different sources. And those pipelines correctly designed will give you more holistic picture of what's really going on. Let's put it that way, is the most general thing I can say, which might be meaningful there, right? And have some insights into how that may pan out. One of the things I was just thinking about, though, when people were speaking, though, is that it's always difficult to crystal ball, and I have a lot of exposure to various things around the world which other people may not have. And one of the things I can say there is that it's very difficult to capture the breadth of the applications of cytometry unless you have a lot of exposure. And people often only think about cytometry in their particular field. But what we should be doing is, this is a career sort of discussion, and particularly for those people who might be listening in and early on in their career, is that there's so many applications that you may not even be aware of. And, let me just cite a couple that, the implications for flow in the brewing industry for monitoring yeast cultures. That's something, if you're in clinical flow, you're probably not thinking about, unless you're downing a few beers after work or something, and it may cross your mind then. But there's applications like that. There's the water quality and water treatment, and in this COVID-19 type age, that becomes increasingly important, that water monitoring applications. As all of us would be aware, with climate change, hopefully there's no climate change deniers on this particular call, there is there's huge applications and implications for cytometry and the measurement of prochlorococcus in the oceans, for example. And that's been going on for a number of years, where we're monitoring what's happening with those small organisms which hold an enormous amount of the world's carbon stores, right? So there's so many applications like that, and it's so diverse that more and more we're seeing that flow cytometry is not limiting so much, but it's actually moving into a whole lot of different areas. Now, that may mean that then some publications relating to flow cytometry, or people go to other conferences to sort of, like Matt was talking about. And that's why I think it's really good to still have some dedicated societies where we can come back to that, that sort of grounding state on what cytometry can do. But yeah, there's no doubt that genomic data and the integration of genomic data, single cell multiomics, will become increasingly important in these sort of human biology and biology research applications. Yeah.
Well, you make an important point. Perhaps the most important point of it all is that places like Isaac are good conference venues to expose yourself to other approaches that people have made. Some of the more interesting talks, ironically, have often been something that I'd never even thought about before at Isaac conferences, I have to say. So yeah, that's something I think to remember, that you're actually part of a very, very broad church, that, or I should rather say community. One shouldn't be religious, should one?
No.
Yeah, so I think...
But for people early in their career, I think that gives you then a huge scope. And it may be that you have cytometry experience, and then you end up on the Aurora Australis, going to Antarctica or something, or whatever it happens to be, right? So there's huge opportunities there. And as I said, little door opens, you want to walk through that and do something different within this great field.
Matt, do you have any comments?
We were on the topic of what's the next big thing in the field for 2 to 5 years.
Yeah.
I think a good case was made by John Rasco in the opening plenary about the emergence of gene therapy, with the impact that that's having, and with the the number of approved gene therapy products doubling worldwide in the last year. Maybe that's not the next 2 to 5 years. Maybe that's the thing now. Actually, obviously I resonate with the discussion about the explosion of data and innovations in how we manage that data and understand and unpack that data. I think is really impactful as well. In my field of platelet biology and megakaryocyte biology, high dimensional cytometry and single cell genomics have really started to disrupt, I think, our thinking in this field. So we're starting to understand now that platelets and megakaryocytes may not be just this single population that we've always thought of, as being fairly uniform, and we've really sort of started to demonstrate that there's distinct subsets, you know, with a lot of diverse and functionally different subsets of platelets and megakaryocytes. So the technology has allowed that discovery, and you know, they may be as diverse and functionally important as what we think of as lymphocyte subsets just within this platelet and megakaryocyte population. So, you know, some of them play a function in hemostasis. Other subsets are more involved in the immune modulation role that that platelets have. So really understanding that, I think, is really going to be quite disruptive in my field in the next 2 to 5 years. And it's really, you know, disruptive concept, and it really has important implications, I think, in how we think of the role of platelet biology across a broad range of health and disease, not just in cardiovascular disease, but their role in defense against cancer and defense against infection and that sort of thing as well. It's really starting to explode.
Yes, oh, that's really good. Thank you. Jennifer, do you see things coming up from your point of view that
Absolutely. I do agree with some of the other speakers here, but I can say that from my research background and my current job now, what we're seeing is an explosion of immune therapies and other therapies, different inhibitors that are coming to the market that are so important for hematology patients, because, you know, having a disease like AML, for example, is not the same from one individual to another, and it's certainly not the same even throughout their treatment. And you see things like clonal evolution. So if we have a molecular marker at the start of disease, it may not be there after a few rounds of chemotherapy, because clonal selection has selected other clones within that AML population, and you see those come up. So in that viewpoint, I think if you're using high dimensional flow with as many markers as we can get in there, to have a look to see what those clonal populations are, and we can monitor those over time, it allows the clinicians to tailor-make medicine. And I think that will give much better long-term outcomes for patients. So I think flow still has a really critical role there, because you can't just do that purely with molecular. You need to be able to monitor in relatively real time, ideally even in the blood, by looking at changes that have happened because there is some disease in the bone marrow, for example. So I think we've got a long way to go, and it'll be a very exciting space.
You make an interesting point, and it is worth always reminding ourselves that you know, just because you see RNA doesn't necessarily mean that you're going to see protein or get protein or even get functional protein, even if you can see protein. These are lessons that I've learned over a long period of time, and most recently with looking at microglia, in which we thought that we had a marker that would be perfect, but it turns out that the marker that we saw was only expressed as a protein and therefore could only use for sorting under inflammatory circumstances. So it's really important to always have that sort of step back, isn't it? It's really, really useful. Hira, do you have anything else to add to that?
No, nothing to add, but I agree with everything that everyone said. I'm learning a lot in this session, by the way. I feel really lucky to be a participant, but also I learn from all of these very experienced people. I feel like every time someone speaks, I'm like, yes, that's right. I agree. So it's really great.
Well, that's terrific. I have to say I'm exactly the same. I'm enjoying it immensely. Steve, do you want to make any other points?
Oh yeah, I mean, it's hard to know what the new technology is going to be, but I mean, from my perspective, I think it's probably going to come from the next big thing, I guess, from computer science, I suppose. Like just thinking about you know, all the data that's being generated, that's possible to generate, you know, high parameter data and genomic data, and also, you know, image cytometry, where you've got not just your parameters of what stains you've used and what antibodies, but also morphological and that sort of thing. Visualizing and dealing with that data is becoming, I think, less sort of intuitive and more difficult to kind of hold in, you know, in your head. And computing, I think computing is going to have a big influence in helping us out with that.
Yes, I totally agree with you. Yes. So I'm going to end on just asking some questions about whether you think the job market's still good and open for flow cytometry, and if you were to hire somebody, who would you? Well, what would you look for? What were the top things that you would look for? Let's start with Vung.
So the job market right now, as it stands, I think we can all appreciate that with the pandemic, there's been a lot of challenges and, you know, sort of limitations to the movement. You know, people sort of staying put in their current positions due to job security more than anything. So, you know, I've tried some recruitment of recent, and it's probably not as many applicants as I've seen in the past. So, you know, but I think as things begin to open up, we'll be able to sort of see that yeah, people will move around, and you know, projects will begin to take place again, and hopefully, you know, more jobs will come through. And with regards to the qualities that I look for in applicants, I guess I've sort of narrowed it down to really 3 key attributes. The first is obviously the level of expertise that's appropriate for the role or responsibilities that you're looking for. The second one would be, you know, sort of interpersonal skills, whether they're able to integrate with the team and the team culture. I think it's important to have a cohesive working and operating team, because that's a team that will achieve things and be most efficient. And I guess the third really is, you know, trying to deduct whether they have good work ethics. And that's probably one of the most challenging ones through an interview, is, you know, putting questions out there that, you know, you try and get a response back to determine, you know, how well they work, how hard they work, whether it's going to be suitable for what you require. So those are the kind of 3 things that I look out for in an interview.
Yes, no, thanks very much. Rachel, you must have done a lot of this in your time. You've got to have distilled a few pointers.
Yeah, I would quite like Hera to come to Cardiff and work. That'd be good. I can spot a sparkle when I see it. Right. Yes. So I can't remember the question. The question is what 3 characteristics?
Yeah, what 3 characteristics, and, you know, is the job market a good one?
I think the job market, so from an academic perspective, the job market is tough, because a lot of our research is funded by charities, and charities have lost a lot of traction over the pandemic in terms of fundraising and etc. And so that is going to take some effort to build back, and also but on the other hand, in other places that there are plenty of jobs and need for the skills. The pandemic has shown that this is where we need to be investing in both blue skies and translational sciences for the future. So I think there's 2 sides to that same coin, and it's really making sure that you can shape a career that perhaps is, in the first instance, less academic and more applied, in order to pay the bills and get that and keep the career going. The kind of person that I would employ, I think it's already been said. I think experience and skills set is really important, and an ability to integrate, and a good attitude, and ability to communicate. And then the other one is to be able to a person that is willing to share their experience and share their expertise, and have that altruistic value, because that's how you get good teams integrating together, and building resilience within a team. And so that's a key value that I look for when I'm employing individuals.
Matt? Thank
Yeah,
you.
I echo a lot of that, and don't really, from an academic and a researcher point of view, I don't really have good news to share. I think I know I understand that there's a lot of international people on the call, but in Australia, the majority of research is funded through a program called the NHMRC, the National Health and Medical Research Council, which is our sort of principal government funding body. The funding rate for ideas grants this year fell below 10%. It was 9.5% of grants got funded. So, as an academic, you look to the left and you look to the right, and you know, in a room of 10 people, only one of you has job security for the next year. So it's really challenging, and really competitive environment in terms of research in the health and medical research field at the moment. And from the university perspective, universities, I think, in Australia are suffering and going to be going into a bit of a period of austerity, I would say, as we deal with, the financial impact, not only of the border closures, but just general other issues that are driving difficulty in getting proper funding to universities. So I think your traditional academic research career has always been tough and is getting tougher and more competitive. I would look at some of the points that Jeff raised about opportunities in commercial cytometry, which I think are probably expanding. So working in industry, whether it's brewing, sounds like a good job to me, but water management, agriculture, there is a lot of opportunities, I think, to work in industry. I think what I look for in a new hire is often its transferable skills and that good fit for the team, ability to communicate and work with others. That is important, absolutely. I'm always looking for someone who can bring something new to the team. So a skill, a technique, a animal model or something like that we don't have that will add value to the team, not just someone who's going to do the work that we do. It's always easy to train someone to do that, but someone who brings something to the team that I don't already have. I think in cytometry, I've already raised this area of big data, and someone who speaks the language of mathematics and also speaks the language of biology is incredibly valuable. And at the moment, I think that is the most value that you can have. If you can understand how to code in R, how to work with big data, and also understand the biology and the question, I think then you are that that holy grail that we're looking for, and you won't have any issues. I think you'll be quite valuable. So someone who works in bioinformatics, particularly with biological knowledge, I think is really valuable there. So I think those are sort of some caveats that obviously it will be quite challenging in the short term at least, but there's ways that you can position yourself to be extremely valuable. I did see in the chat there was someone asking about the importance of a PhD in a cytometry career. I think probably it would depend on what you're doing in the cytometry career. Probably maybe Vung and Jennifer, you can comment. In clinical cytometry, you need a qualification. It's very, very important to have that qualification and training as a medical scientist and have the understanding of hematology and immunology in order to operate in that space. But I'm not sure that you'd reach a career ceiling without a PhD very early, I think. But in a research career, the PhD is often considered quite important. It's a way of demonstrating that you're able to see a complex project through. It shows that you have the problem-solving skills, that you take ownership of issues and can solve those problems and work with teams as well. That you can communicate your science and your ideas, and that you can plan experiments. There are other ways of demonstrating that as well, of course, through experience as well, but PhD is a good way, I think, just to demonstrate that you have those abilities. And it unlocks a career ceiling for you. So it might be actually harder to get a job in the short term with a PhD, particularly if you're looking in this academic research career. But in the long term, I think it unlocks that career progression a little bit further than it would be without a PhD. So I would still recommend, if you can, looking for opportunities to continue your research career if that's what you want to do. I'll stop talking. I've talked too much already.
Thanks, Matt. I think that's all a very valuable point. Look, I'm going to actually now see if we can open the floor to people who want to ask questions. The time has, of course, as always with these things, got away from us, and we have something more than 10 minutes to ask a few questions. So if people would like to either put up their hands and unmute themselves and ask questions, or type some questions into the chat, that's also legitimate. I can ask them just to see whether we've covered all of the things that people want to hear about, I guess. Yes, Eric.
Hi, good day, everyone. Thanks for the fantastic discussion this morning. Maybe it's just a bit of a curveball, but it's also maybe tied to the question about needing a PhD or some form of like master's degree in career advancement side of things, or even getting into flow cytometry or just cytometry in general. So this is something that I have seen as a bit of a struggle understanding the market and things like that. That kind of thing is there what kind of salary grading? This might be a touch on a runner kind of thing, but what kind of salary grading do you guys see in this field? Also for any juniors listening, whether they're looking into this aspect as well when you're looking at this form of job. Is this something comparative to, say, a postdoc degree, or are we expecting, if you're saying you're coming as a junior, you have a sort of like lower salary grade? What kind of traction or career advancement is there? Say, for example, in larger teams, the other question is, in larger teams that you have in a core facility or something like that, do you have multiple levels, like in an RA position, you got RA 1 to 6, that kind of thing? But in flow cytometry teams, do you have this kind of you are flow cytometry junior, senior, mid-level, and then what kind of career progression do you get? How easy can you get, if you are aiming to become a manager in the facility? Because some of you are in that manager position, some of you probably have been in the manager position for like a long time. What does that show to the juniors? Would they be able to move up to that position because someone has been in there for like 10 years, 15 years, that kind of thing? That's some out of interest.
Well, let me throw that open to the panel. I guess Jennifer and Hira and Steve are, in a sense, at this particular coalface that Eric is talking about. Do any of you would like to comment?
I can comment from the clinical side. I think having a PhD is not necessarily essential to climb the ladder, but it certainly does help. I guess in the research field, there is different gradings to what you have in the hospital system, but I think there's also a difference between public and private facilities with clinical flow. So it's greatly varied from my experience.
Okay. Avril, you probably could also comment on this, I think.
Yeah, happy to. So I guess it's interesting to hear you say, Jennifer, that there's definitely different gradings, and there are. So I don't know if you've seen that there's career trajectory in the clinical side for flow. Is there a set hierarchy of structures and career progression already built into your system? Because I can say for certain for research, there's not a lot on the research side. We don't have advanced structures in sort of, especially the university and medical research field. There's not existing structural tiers, or not a lot.
Yeah, there definitely is in public health. But in saying that, you don't need the PhD to get to the next tier necessarily. So a lot of it's based on experience and so forth. So, but I think the private sphere may be different. I'm really not quite sure. I'm happy to sit as my scientist and just that's where I want to be. So
yeah, yeah, I must say I'm happy in my role. I feel my time, but more than I can meet demands. So I'm quite comfortable where I am as well. But I think, so I guess, Eric, your question, you were interested to know if there's an existing structure in place for career development. I know that's a tricky topic across all of cytometry. It's an interesting point that Sash, who was recently just at QUT, he has a really cool proposal that he implemented there, and they've basically generated and created their own stream of career development, their own type of hire. So rather than being professional or academic, they actually have a midpoint that they've created at QUT for technical staff. So staff have a career progression available to them through a different tiered structure in a QUT. And that's something he's been promoting for a few years, but it hasn't actually gained traction yet. And I think it's something that would be really cool if we could reach out to SASH as individual organizations and start maybe promoting that idea across our organizations, because it's something that we don't have as part of the, at least for the research side, we just do not have an existing career structure. You know, you've got your technical specialist, you might have a senior technical specialist, and then really you kind of tick over straight then to the facility manager or director. And then there's not a lot of structure there to develop.
Yeah.
Yeah, it's hard. And it states it, sorry, Matt.
So can I make a comment there, having been on both sides of the fence for a long time? So, you know, I came from a purely just technical role in medical research, and I spent 25 years in academia there, and I actually jumped without a PhD from technical side to holding a faculty position at University of Queensland. And before I left there, I was academic level D, if that means anything to you, if you happen to be in the academic system. So, so I had a faculty position without a PhD, and because you're a specialist in a particular area. So what I would say is that you can get right up to, you know, high level within there, putting in lots of unsuccessful NH and MRC grants, just like Matt, and on that merry-go-round. But you can do whatever you want within your career, essentially, in my opinion, and don't be limited by the structures that are necessarily there. You need to think about how you can move within those structures by having appropriate skills which make you attractive. And if it's to be in the public system or in the academic system or in a commercial system where I am now, if you position yourself appropriately so you have skills that make you attractive, then you won't be hemmed in by necessarily the structures that are there. Now, to make yourself attractive, if that means that you have a PhD, for example. But just on that note, I didn't make a comment on the last point, but what do you look for in a job candidate? For me, the key thing is a diversity of background. Right. And so when I'm looking to employ people, I want to have people who have a skill set which gives them a different perspective on how they're going to approach solving a problem. So I've just employed someone. Now he's been employed in an engineering role, but he has a PhD in immunology, and he's been working on developing a wrist glucose sensor device, right, for a small university here. So that's the guy I've just employed. The guy I employed before that was the principal engineer for the LASIK system that does the eye surgery. Know nothing about flow cytometry. I don't care if they don't know about that. They have a skill set which makes them attractive and a diverse background and problem-solving ability. And Matt touched on that point before, that, you know, getting a PhD, which I don't have, by the way, even though I held a full academic position, that shows that you can solve problems, and that shows that you can think logically and come at a problem and work all the way through it. So I think just try and take those lessons on board, Eric. Yep.
Yeah, thanks, Jeffrey. I was actually going to ask you, I'm glad you dipped in. Rachel, do you have any further comments?
I've forgotten what the question was.
Well, I think the question was about the sort of structure of cytometry, and Jeff really saying, don't let structures get in the way of you, really.
So I completely agree with that. I think if you show that you're a real asset in some particular way, you'll be surprised how an institution will will bust a gut to keep you. And I think quite from a higher education institution, I think we have to be creative in the types of individuals that we employ. Otherwise, we are not going to be competitive and diverse enough compared to other types of institutions, and I include industry in that as well. So I think we'll see a change. I think COVID-19 has shown us that there's lots of diversity in talent that is needed in order to develop and deliver an agile scientific discovery and make it translational and bring it to a patient. And I think we're going to have to change our attitude to what kind of team that requires, and it's going to be based on skill, attitude, and diversity of talents rather than what degrees you actually have. I think we have to start being much more open in the kinds of individuals we need.
Okay. I think with that, I'm going to bring this wonderful panel to a close. I thank you all so much for being part of this. The plenary session is going to start in the next couple of minutes, and so I don't want you to lose out on that, those of you who wish to see it. Look, thank you to all of our panelists, Matt and Vung, Hira, Stephen, and especially Rachel and Jennifer and Jeffrey for contributing to the discussion that is obviously been terrifically engaging for a number of people, judging by the responses. So thank you all, and thank you, Avril, for organising this.